As we start Chapter 9, we're going to return to an idea we saw all the way at the beginning of the course, which is the idea of identities. What we're going to be doing is essentially little mathematical proofs, where we're going to see if we can find out that two trigonometric expressions are actually equivalent to each other. Now, it can be a little challenging, but it's also a pretty fun little puzzle sometimes too. Let's take a look. Everything that we've seen on these next two slides, these are the identities that we've already established. We started with the Pythagorean identity that cosine squared plus sine squared could be 1. We showed that in an earlier video. And then you could divide through by either cosine squared or sine squared all the way through to create these alternative versions. These are going to be real useful tools as well. We talked about the even and odd identities. I'm not going to go back through all these, but we established these earlier. These can be useful tools. And then lastly, they're calling these special names, but everything on this slide are just definitions that we know about these trigonometric functions. We've already used all of these. So the way we handle solving an identity, or proving an identity, I should say, is that we're going to use those truths that we already know. We're going to use substitutions to rearrange. Now, they have kind of a side idea here real quick. If you wanted to graphically tell whether two trigonometric expressions are the same, like the left and the right are telling the same story, you could graph them on something like GeoGebra or Desmos or whatever. And if you graph them separately and you've created the same graph, well, then they're the same thing, which we know obviously that cotangent is the same as 1 over tangent. We already know that. But if you graph them and got the same graph, then they are. Okay, now here's the way we're typically going to do this. What we're going to do is we are going to use substitutions in algebra to try to see that the left side and the right side are actually the same thing. Now, a very important word of caution here. It's got an equal sign here, but this is not established yet. This is not an equation in the sense like 3x plus 2 equals 13 or something, and we would just swing the 2 over and divide. We can't. This isn't truly established. What we're going to do is we're going to work on the left side to make sure we can turn it into the right side. And at that point, we've established a truth, but it's not the same. It's not an equation in that sense. Okay, so the most basic way to prove one of these trigonometric identities, sorry, stumbling with that, that's not easy to say, is we're going to just substitute a definition, a simple definition. Tangent can also be written as sine over cosine. Now, it's substitution and algebra. So I've substituted that in. Isn't that the same as tangent? And then you can cancel the cosines. Just follow the normal laws of algebra. And we have found that the left and the right turn out to be the same thing. Okay, let's try it again. You can try this on your own. Or I'm going to go ahead and start tackling it here. I'm going to just make the basic substitution of the definition. Okay, so let's substitute. I just substituted one simple definition here. And yeah, you know what? Well, let me start with this. So far, here's what I have. I've got cosine of theta over sine theta times tangent of theta. So I made a simple substitution. Now, after the substitution, do some algebra. Just multiply these together. Now, we want to see if these are going to turn out to be 1. Well, I know they will be, because tangent is sine over cosine, and everything's going to cancel out. But so this didn't solve it for me. I made a substitution, I tidied it up, and I'm not done. Let's try another substitution, see if there's something else I can do. So what I can do is tangent is the same as sine over cosine, right? Now, we're back to algebra. Cancel, 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 cancel. All those cancellations leave behind a 1. So I got there. Okay, so here we've got this very complicated left that we're trying to turn into sine squared. So let's get started. What we're going to need here is we're going to go back to this idea. So we need a substitution, unless there was like some obvious algebra right off the top, but I don't really have anything. There's actually a couple different ways we could do this, but usually there is. But I'm going to start with this idea that we know from the alternate to the Pythagorean identity, this is one of the alternatives, that secant squared can be called tangent squared theta 1. So again, there's multiple ways you could do this, but they're going to just start with a simple substitution. I'm going to use the alternative version of the Pythagorean identity to give me this. Now, let's do algebra. You see the ones would cancel. So here I am now down to tangent squared theta over secant squared theta. Okay, well, we're not there yet, so we need another substitution. So they've just separated these here. Actually, they're still just doing some algebra. But here's what we could separate. Secant squared in the denominator. Isn't this true? So secant squared is 1 over, they didn't really show this quite right, or they went a little too quick. Isn't secant squared 1 over cosine squared theta? That's what it is. So they jumped ahead a little quickly. But if I had 1 over cosine squared theta on the bottom, I made a substitution. Now I'll do some algebra. That's going to make it, it's going to keep change flip, it's going to move to the top. So secant squared theta on the bottom can become cosine squared theta on the top with a substitution and a little bit of algebra. Okay, now what do we got left? We're trying to get to sine squared. So this didn't get us there. Let's make another substitution. Tangent squared, by definition, is sine squared over cosine squared. Well, these will cancel, and I'm left with sine squared of theta, which is what I was hoping to do. Okay, let's try another. Now remember, we cannot multiply across here. This is what we're trying to prove. It's not an established equation. So we could do this several ways. I'm going to start with this substitution. Cosecant is 1 over sine theta. Isn't that the definition? And the reason I started with this is if I have the fraction on the bottom, it'll just move it up to the top. Okay, now this hasn't proven what I wanted, and I've done my algebra. There's nowhere else to go, so it must be time for another substitution. So cotangent is cosine theta over sine theta. Now I've done a substitution. Let's do some algebra. And I got there. Cosine of theta. Okay, now I don't like this kind. I don't test someone on this, like turn it into strictly into a certain one. What I like these where it's hard enough, I think, for people, especially as they get a little harder. So what I would suggest to people is these kind where I'm telling you exactly what I want it to become, and you can just prove that. Here what they're saying is, they'll see this where I want you to rewrite this so there's nothing left but sine functions. So it's not terribly hard, but not the kind I prefer. So look what they've done here. They've just done all the substitutions at first, and their goal is they're trying to get down to nothing but sine functions. So they've made their substitutions, and now they've multiplied. We get this. Well, how are we going to get down to just sine functions? Well, the Pythagorean identity is going to be super helpful here. Remember, we had cosine squared theta plus sine squared theta equals 1. So we could rearrange this and say cosine squared theta must be 1 minus sine squared theta. Has to be. That's true, so this has to be true as well. So they're going to make that substitution, and we got where we wanted. They wanted everything with sines. Well, there it is. Okay, that's a real basic introduction. We're going to do plenty more of this, more than you probably want to. But we're just taking our already established definitions and identities, and we're using those as tools. The way you do this is make a substitution, do some algebra. If you're not there, make another substitution, do some algebra, until you keep manipulating it to get where you want. Just remember, you cannot multiply across the equal sign, okay?